top here, I kind of gave you some things to look for to help you be successful when you're doing your word problems here. You want to generate a few terms, try to figure out what kind of a sequence you're dealing with if you can't easily figure it out from the words. Read carefully and identify what it is you actually need to solve for, and also list out what it is that you know, and then use your formulas and your list of your knowns to solve the actual problem. So our first one here, we have a ceramic tile floor is designed in the shape of a trapezoid where it's 20 feet wide on the top and 10 feet wide on the bottom. So up top is 20 feet, bottom there is 10 feet. The tiles, which are 12 by 12, which means they're 1 foot by 1 foot, are going to be placed so that each successive row contains one less tile than the preceding row. How many tiles are required? So, is this arithmetic or geometric sequence? Arithmetic. We know it's arithmetic because it says right here it's one tile less. That means we have a common difference here of -1. Each row has one less than it did the row before it. So we're trying to figure out how many tiles are required. So what are we looking for here? Nope. The sum. We're looking for the total sum. Taking the ones from row 1, adding it to row 2, row 3, all the way until we get to the bottom. So our sum formula, also known as your arithmetic series formula, is what we need to end up using here. So based on our picture, do we know n yet? No. We don't actually know how many rows we have yet, so we got to figure that out. Do we know our a sub 1? Yeah, right at the top. It's 20 feet. Since the tiles are all 1 foot by 1 foot, that means I'm going to need 20 tiles in my first row. So my first term is going to be a 20. How many tiles in our last row? 10. So I know my last term. And the only thing I really need to have now in order to do my series formulas, I need to know what the value of n is. So that means we're going to have to go to our other arithmetic formula. And this happens a lot. You have to go back and forth between the two of them in order to be able to answer your problems here. So again, I'm trying to figure out n. So for my a sub n, I put in my 10. My a sub 1 is 20. Our common difference we determined was -1 because each row has one less tile. So subtract my 20. Divide by -1, and what do we get? 10. So then add my 1 over. And we get that n is 11. So we have 11 rows here. So now we can go plug into our series formula. So 11 divided by 2 times 20 plus 10. And how many tiles total are they going to have to use? 165. Now, once you actually buy a house, you'll learn that you actually have to go about 5% more than that, just in case you have any errors or mistakes in your cuts. But 165 is what it should take. So question number 2, we have the Clinton Theater has 25 seats in the first row and 30 rows in all. Each successive row contains one additional seat. How many seats are there in the theater? So what kind of a sequence do we have? Arithmetic again. This time our common difference is a +1 because each row going back has one more seat than the row before it did. So we have a common difference of 1 here. So again, they want us to figure out how many seats are there in the theater. So that means we're looking for a total. So which formula do we have to use? Our summation again. Or our series, I should say. So again, for our series formula, we need to know our n. Do we know n? 30. So there's 30 rows of seats. So our n is 30. We need to know our first term, which would be 25. There's 25 seats in that first row. We also need to know our last term, which in this case would be a sub 30. That's the one we don't know yet. So we got to figure that out so that we can use our arithmetic series. So again, using our other formula, 25 goes in for our a sub 1, 1 goes in for our d, 30 goes in for our n. And what is our 30th term? Now we can plug into our series. 30 goes in for n, 25 is our first row, 54 is our last row. And how many seats do we have total in the theater? $11.85. So again, figure out what kind of sequence you're dealing with, then you know your formulas. Number 3, we're going to revisit the whole pendulum problem that we had before. Initially, a pendulum swings through an arc of 18 inches. On each successive swing, the length of the arc is 0.98 of the previous length. So what kind of a sequence is this? Geometric, good. Our common ratio would be 0.98. So after 15 swings, what total distance will the pendulum have swung? So this is our geometric series formula. So let's see if we have all of our information. Do we know our a sub 1? Yeah, what is that? 18. Do we know our n? Yeah, what is that? 15. It's after 15 swings. And I already have my r listed there. My r is 0.98. So we have all the information that we need to know. We can plug this into our formula. So 18 times 1 minus 0.98 to the 15th divided by 1 minus 0.98. Go ahead, type that in, and we'll go to the nearest tenth for our answer. Anybody get the answer yet? So after 15 swings, it has traveled 235.3 inches. All right, let's try another one. So here we have Mike has started out the year in Algebra 2 slowly, earning test grades of 48, 50, 52, 54. He's progressing. So write an explicit expression for this sequence. So when it asks you for that explicit expression, that's one of the formulas. So first off, what kind of a sequence do we have? Arithmetic. His test grades are all increasing by 2. So here's our arithmetic formula. So plugging into that gets us our explicit expression. So our a sub 1 is 48. Common difference is a 2. So distribute your 2, combine your like terms. What does our equation end up being? N plus 46. So now they want to know, what did he score on his 15th test? Plug in a 15. What did he get on that 15th test? 76. So it says we'll take 20 tests over the course of the year. What will be his total for his test scores? So which formula are we using now? The series one. So our n is a 20. The only thing missing from this one is what he got on his 20th test. How can we figure that out? Yeah, plug it into the explicit formula. So 2 times 20 plus 46. What was his 20th test score? 86. 48 plus 86 times 10 gives us what? Is that what I got? Yeah, I had 1340. I thought you said 4,000. Oh, I'm going deaf. You gotta talk. Okay, so that's his sum of his 20 scores. So then how do we figure out his average after having that? Divide by 20. So what was his test average? 60 something. So once a month, David deposits money into his savings account, putting 50 cents more into his account each month than he did the previous month. So after 12 years, excluding interest, he has $5,436 in his account. How much money did David deposit in the first and last month? So first of all, what kind of a sequence do we have? No. Arithmetic, because he's putting 50 cents more in each month. So that's a constant amount. That's his arithmetic. So here's my 2 arithmetic formulas. Again, we're trying to figure out how much he deposited in this first month, because it wasn't 50 cents, and then we're trying to figure out how much he deposited in his last month also. So I'm going to start with my series formula over here, because that has my first and my last month within it. We have the sum. So I'm going to put that in for S. How many months total over 12 years? 144. 12 months for 12 years, 144. So that means I need to have my first term a sub 1, and I need to know my 144th term. So my a sub 144. And then that's where we kind of get stuck in that formula. So I'm going to jump over here to this one. If I were trying to figure out my 144th formula, or deposit there, I would have to take my first term. Our common difference is how much? 50 cents. And again, my n is 144. So we can simplify this stuff over here. So 50 cents times 143 gives us what? 71.50. So then we kind of get stuck again there, because now there's nothing else we can do because we still don't know our first term or our last term. But what we can do now is we can take this and substitute it over there, because by doing that, all I have now are a sub 1s. Now I just have that one variable of a sub 1. So outside of my parentheses there, what is 144 divided by 2? 72. So I'm going to simplify that to 72. So now I can divide both sides by 72. So it's 54/36 divided by 72. We got 75/50. A sub 1 plus a sub 1, 2a sub 1. Just kind of like it would with your x's. X plus x would be 2x. A sub 1 plus a sub 1 would be 2a sub 1. So subtract our 71/50. And we would get a 4. Divide by 2, and what is our a sub 1? So I got one of them. A sub 1 is a 2. So then I can go back over here and plug it in. And what is our a sub 144? 73.50. So again, you have to be able to manipulate both. Sometimes you got to plug one of them in, but it'll be there. All right, so we have a triangle. It's an equilateral, so all of the sides are 24. So then I connect its midpoints to make another triangle. So what would be the lengths of that triangle? 12. Yeah, because you're connecting the midpoints, so those would all be 12. So then from my 12, I connect those midpoints. So those sides all become 6. And then 3. And then I can't write on my little light blue triangle because it's too small, but that would be 1 1/2, 1 1/2, 1 1/2. So they want to figure out the sum of the perimeters. So, what is the perimeter of my biggest outside triangle? 72. What is the perimeter of my next triangle? The perimeter of my third one? 18. So what kind of a sequence are we starting to look at? Geometric. What would our common ratio be? 1/2. You're multiplying each one by 1/2 to get you down to the next one. So we're dealing with the sum. So that's going to be our geometric series formula. So a sub 1 times 1 minus r to the n, all over 1 minus r. So our n is going to be 10 because they're looking for the first 10 triangles. Our a sub 1 is 72. So we'll go to the nearest tenth for this one. So go ahead and type it in. Nearest tenth, what is the sum of the perimeters of the first 10 triangles? Should get 143.9. Alright. So you should be using that geometric series formula for this one because I gave you her sum for those first 6 years. We're trying to figure out what is her first term. I'll give you a minute. Alright, let's take a look at number 8 here. We have a mason stacks 25K bricks in such a way that there are 15 bricks in the top layer and K layers all together. If each layer contains 2 more bricks than the layer immediately above, find the total number of bricks in the stack. So, let's take a look at what we know. We know that the sum of all of the bricks is 25K. K is just a variable. We don't actually know what it is. It's just there. We know the top layer has 15 bricks in it, so A sub 1 is going to be 15. N is the variable K. They said there's K layers worth of bricks in there. So what kind of sequence do we have here? Arithmetic, because each layer has 2 more than the one before it. So our common difference here is going to be a 2. So which formula should we use? Yeah, the arithmetic series one. So as I'm plugging into that arithmetic series formula, we run into the problem of we don't know A sub n. So we're going to have to use our other formula to be able to figure out our A sub n. But again, for n, they told us to use the letter K, so really it's our A sub K. So that's going to be the first plus the common difference times K minus 1. So distribute our 2, combine our like terms. We get 2K plus 15. So our last layer is 2K plus 13. So cleaning up inside my parentheses here, I got 28 plus 2K times my K over 2 equals my 25K. Now there are a lot of different ways you can go about solving this from this point. So I'm going to give you a minute. I want you to go with whichever method works for you. Go ahead and finish solving that. So you should end up with K equals 11. I also had a K equals a 0 from when I did my GCF factor here, but I can't have 0 layers of bricks. That doesn't make any sense. So my K equals 0 gets rejected. K ends up equaling 11. So then your last step is your 25 times 11 to actually figure out how many bricks were there, which was the whole point of that question. You get 275 bricks. So we got Susie starts a savings account she puts in $5 on the first week and increases the amount by $2 each week. How much has she saved at the end of at the end of 1 year? So, she starts with $5. That's our A sub 1. She's putting $2 each week, $2 more each week. So, arithmetic or geometric? Arithmetic. We'd have a common difference of 2 because she's getting $2 more each week. And then our N would be what? 52. Because they're talking about weeks. They tried to throw you off by saying 1 year. But they want to know at the end of 1 year, which is 52 weeks. So in order to do our summation formula, what's the one other thing we need to know? Yeah, we need to know that last one. Since it's arithmetic, we need to know how much she has deposited on that 52nd week. So first term plus common difference times 52 minus 1. So how much money did she deposit on the last week? $107. So now we can do our series. So how much did she deposit in 1 year? Should get 2,912. So then suppose Susie chose to increase the amount each week by 8%. Would this allow her to save more money at the end of the year? So if she changes it to increasing it by 8%, what kind of a sequence is it now? Now it's a geometric one. So we still have, starting off first term is $5. Our common ratio would be 1.08 because she's increasing by 8%. And our N is still going to be 52. Still doing it for 1 whole year. So plugging it into our summation formula, first term times 1 minus your rate to the 52nd power, divided by 1 minus your rate. Should get 3356.63. So would this allow her to save more money at the end of the year? Yes. You gotta make sure you actually write that word yes, because that actually answers the question. So that is of importance there.